So there we're looking at the properties of limits. That's the basic thing that we're doing there. Properties of limits. Properties of limits. The first property here is that, well, if I have a limit as x goes to some number c of f of x multiplied by g of x over h of x, then feel free to do this of f of x multiplied by the limit as x goes to c of g of x, and then divide by the limit as x goes to c of h of x, provided that those limits can be found. Provided that the limits are, provided the functions are continuous. Okay. Then 2, the limit as x goes to c of a constant a is equal to a. Like that. And then the limit is very, very complicated. The limit as x goes to c of, maybe let me say, root of some function g of x plus h of x. This is the same thing as the root of the limit as x goes to c of g of x plus the limit as x goes to c of h of x. This is the case. So meaning if I have subtraction or addition, the limit can distribute throughout. It can even enter in the root, doesn't care. So now let's see. Example. Coming from question 3. A. Before A, we are given some things there. Given that the limit as x goes to 12 of f of x is equal to 2. The limit as x goes to 12 of g of x is equal to 6. And that the limit as x goes to 12 h of x is equal to 9. Then you're saying compute for A, the limit as x goes to 12 of 1 h of x multiplied by f of x plus 1 plus g of x over g of x. So following the properties, this is the same thing as the limit as x goes to 12 of h of x, the limit as x goes to 12 of f of x, plus the limit as x goes to 12 of 1, plus the limit as x goes to 12 of g of x, over the limit as x goes to 12 of g of x, like that. Then this is equal to, let's substitute. So the limit as x goes to 12 of h of x is given here as 9. So you put 9 there, multiplied by f of x is given here as 2. So we put 2 plus the limit as x goes to 12 of a constant is a. So 1 is 1, plus the limit as x goes to above g of x is 6 over 6. So we're getting 9 times 2, that is 18, plus 7 over 6. So we can do 6 down, and then 18 by 6 plus 7. What is 18 by 6? Those who are good at multiplication. Those who are good at multiplications. They're no longer good. Okay.
It's 108, sir.
108. So
Yes.
plus 7. Plus 7, we get
115.
115.
Good. So this is the answer. If you want, you can simplify. 3 can go in there and down. If it can't, then we're done.
Sir,
Yes,
I had a connection problem, so I'm lost.
you're lost, right?
Yes.
So don't worry, we'll find you.
Yeah.
So now we look for you. So we're saying we have got these properties that are guiding limits. That if I have the limit and then there are functions f and g multiplying over h, or you can distribute the limit. You get the limit first for f, and then get the limit for g, then get the limit for h. Then you multiply the limits and then divide. Just where they are sitting, the limit can be distributed like that. So if that is the case, we're also saying if you're looking for a limit of a constant, you still get the same constant. Then if I have a root and there are functions inside, now the limit for the whole thing, I can as well take the limit inside the root. I get the limit for g and for h, then I add them. That would be my answer. Now here in the question, we are given the limit for f to be 2, the limit for g to be 6, the limit for h to be 9. Then we are given to find the limit as s goes to 12 of h multiplied by f plus 1 plus g over g. Now, because the limit can be distributed, we distributed the limit for h, the limit for f, so limit for h, limit for f, plus the limit for 1, plus limit for g over limit for g. But we have them here. The limit for f we have, the limit for g we have, the limit for h we have, the limit for 1 we have. So we have just used what we have.
But so this hx f of x plus 1 plus gx over g of x, is it something like a formula or?
No, this is just like any combination that the examiner wants. We just combine them in this one.
Oh, I get it. Thank you.
Okay, so then what about, that was A, what about B? B is the limit as x goes to 12 of f of x plus 1 over 3 by g of x minus 2 by h of x. So this you can write as the limit as x goes to 12 of f of x plus 1. Okay, we have now stopped writing the limit for 1 because we know it's just 1. And then over 3 outside, then the limit as x goes to 12 of g of x minus 2 outside, then the limit as x goes to 12 of h of x. Because we know even if we say 2, its limit will be 2. So it's just the same as putting the constant outside, then you get the limits. Then now the limit for f, we are told it's 2. So 2 plus 1 over 3. The limit for G, it's 6. Minus 2. The limit for H, that's 9. So working out 3 over 3 by 6, that's 18. Minus 18. So we get 3 over 0. It's undefined. It's undefined. That is the answer. Okay. So I'm adding to the exercise. Remember in the other one I gave you question 2. Now here I'm adding question 3. C. The limits are given. Yours is just to do the expansion, or just send the limits there and then multiply the numbers that you get. Okay, we're now going to question 4. Question 4. A, what's the limit as t goes to 0 of t squared plus 6 over t squared minus 3? Oh, this is a very simple question. Just where there is t, substitute 0. So we have 0 squared plus 6 over 0 squared minus 3. This will be 6 over minus 3, which is negative 2. We're done. So it's very, very easy. Just substitute directly. Is it that easy? Let's see. The limit as w goes to negative 2 of w plus 2 over w squared minus 6w minus 16. Okay, let's substitute. Minus 2 plus 2 over minus 2 squared minus 6 by minus 2 minus 16. This will give us 0 on top. Then that's 4 plus 12 minus 16. This is also 0. This one is complicated now. So what do? You come back and factorize this guy. That's the first method. You come back and say, okay. What I'll do is I'll factorize the denominator. So we'll have the limit as w goes to negative 2. The denominator is just w squared minus 6w minus 16. So if you multiply 8 by 2, we get 16. So one of them must be negative. So it should be negative 8. So you have w squared minus 8w plus 2w minus 16. Then you have w minus 8 plus 2w minus 8. So w minus 8, w plus 2. So you come here and say w plus 2 over, this is now a product, w minus 8 and w plus 2. So this and this can cancel. Well, now we have w goes to negative 2, 1 over w minus 8. Let's try and see if we can now substitute 1 over negative 2 minus 8, giving us 1 over negative 10. This is the limit. So if I get this situation, I must be worried. So I come back and do something to the function to take away what is making that 0 over 0 there. This was solution 1. Or we say, okay, I've gotten 0 over 0. That's good. If I get 0 over 0, then I'm saying because I got 0 over 0, then I'll change the approach. I will differentiate with respect to W, the numerator, and differentiate with respect to W, the denominator alone. How do you differentiate? This one just use power rule. So you get the limit as W goes to -2. You differentiate W, you get 1. Then differentiate W squared, you get 2W, and then minus 6, that will be 0. Then now you substitute. You have 1 over 2 by -2 minus 6. That is 1 over minus 4 minus 6, which is 1 over minus 10. Done. Very nice. See, the limit as t goes to 8 of t minus 5 minus 24 over t squared minus 8t. So again, you try this, substitute 8. We have 8 minus 5 minus 24 over 8 squared minus 8 by 8. That is 8 by 3, 24. It was 8 minus 5, that is 3. 24 minus 24 over 64 minus 64. That is 0 over 0. So now, this time around, nothing like we start thinking what to just expand that guy and get tx squared minus 5t minus 24 over t squared minus 8t, and then differentiate. So we differentiate the numerator, we get 2t minus 5. Differentiate the denominator, we get 2t minus 8. Then substitute. So we have 2 by 8 minus 5 over 2 by 8 minus 8. That is 16 minus 5, 11. 16 minus 8, 8. Wonderful. Or you factorize, look for the factors, 8 and 3. They will help us to break the numerator there, and then down you factor out t. And then the t minus 8 will cancel from up and down. So we get that one. Like that. D, very nice. The limit as h goes to 0 of 2 plus h.
So we said we factorize and we differentiate.
We factorize and if you factorize, don't differentiate. If you factorize, you can't.
All right. So
The one where you differentiate, look, we have two options. I said the first or the differentiating. The first is where you factorize and cancel and subtract. Or you differentiate and subtract. Okay, what about this one? 2 plus h, 3 minus 8 over h. So the way it is sitting like this, we know we have an issue here. So let's substitute direct. We'll get 2 to the power 3 minus 8 over 0, which is 0 over 0. So it's just to differentiate if I want. So I'll differentiate the numerator. I'll get 3 and then 2 plus h squared over 1. If I differentiate the denominator, then we substitute now. So we have 3 by 2 squared over 1, which is 3 by 4, which is 12. Or you expand. Now we have done binomial, so that's an easy expansion. 8 plus 3 by 2 squared by h plus 3 by 2 by h squared plus h3 minus 8 over h. So this and that becomes.
Sir,
Hello.
sir, I have a question. Why have you put 2? Limit as it was as h approaches 0, but you've put 2.
I haven't put 2. Where there is h, we put 0. So we remain 2 plus 0 is 2.
I see what I'm asking. 3 open brackets 2 raised to the power 2
Yes.
over 1.
Because it was
Now, why
supposed to
have
be
we
it was supposed to be 3, 2 plus 0 to the power 2.
Oh, okay, sir.
So because we've taken away the constants, whatever I've meant here has h in it, h. So now we have the limit as h equals to 0 of 4 by 3, that is 12h plus 6h squared plus h3 over h. Factor out h, so the limit as h equals to 0, then h, then 12 plus 6h plus h squared over h. So at this h and this one will cancel. Then now we can substitute where there's h. So we'll get 12 plus 0 plus 0, which is 12. Well, we got there. Okay. I don't want you to get that, so we end here. We continue next time. But do those questions I've given.
Yes, sir. And you should send the recorded video, sir.
All right.
The first one. Yeah.
No problem. I'll send them later.
All right. Thank you.
After I receive the exercise. All right. Oh, and what should we touch before we go? And what should we look at? We are looking at the coverage. So the basic thing is, well, we are given, look, trig, exponential, log, and then we have, what else do we have? Partial, binomial. These, we have the tutorial sheets, plus we have the quiz papers. Those quizzes written are telling us how he wants to bring questions from these topics in a way. But we also have the tutorial sheets because he didn't bring out all the tutorial questions. So he got some put in the quiz, or he may use some in the test. And then we have matrices. Matrices, you just need to know the determinant. 1, 2, you need to know the inverse. And then 3, primary. You're done. Then vectors. Vectors, just go for the terms. What do they mean when they say parallel vectors? When they say unit, or when they say unit opposite. Okay. Or when they give me a magnitude. What do they mean by dot product? What do they mean by cross? How do I get the volume? How do I know two vectors lie on the same plane? Those are things that you're asking. So then calculus, that's where we are now. We're talking about how to differentiate, how to find the limit. Okay, should they give me a graph and then should they ask me to sketch? If they can ask you to sketch, am I able to sketch what function? Depending on which function they have brought, we're still going through, look at different functions here, and then we'll be able to discuss how to sketch. Then how to differentiate the methods, integration, application, then you're set for the test. You don't need to worry now. Remember, our biggest task here is to prepare for 70%, which is the exam. Okay. And if you have to be fair enough to yourself, whatever we do here, you go through. And make sure that you understand. If you understand, then you're cool. The minimum we can get in the exam is to have cleared it. Then you forget about it. Hearing is a must. Just do what you're doing here. You can forget about other things, just do what you're doing here. It's enough. And they're going to clear.
Sir,
Uh-huh.
please, we should do
As
some
the
graphing.
coverage, there is no calculus.
Please. The whole calculus. I think it goes up to sheet 11.
All right, sir.
But I will do the graphs, we'll still get back, yes?
Yes, I'm the one who was talking about the graphs.
Mm-hmm. We'll do the graphs.
All right.
Mm-hmm. So I think we'll change the approach a bit. We're supposed to go back and start planning for the exam from sets, but then what we'll do is, because of the test that is coming on the 2nd October, and this coverage is a bit wide, so we invest much on the test. Knowing that as we are investing much on the test, when we reach 2nd October, then would have done from trig up to calculus in depth. Then from 3rd October, we'll go straight to statistics and probability. That should be done before 10. And then we go back to sets up to before trig, meaning up to polynomials. This is just like from 10th to maybe 16th. And then now we start getting the whole course up to, but time is gone. There's not much time to relax. That's why we spend this much time like today. We also want to finish before the break so that we have 2 weeks to just go through also on everything has been taught. We're just asking questions, just follow up questions to see if you're okay. I give you some assessments here and there to be ready for the exam. Okay, we end here. Don't worry, guys. There's nothing hard. We're all going to prayer here. Want or not.